Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about nucleophilic aromatic substitutions. Substitution reactions in which the nucleophile displaces a good leaving group. Just remember, in which the nucleophile displaces a good leaving group such as halides on an aromatic ring. Reactions that are successful at an aromatic substrates are largely of four kinds. Electrophilic substitutions is by far the most common mode of substitution in aromatic system. The nucleophilic substitution is indeed a useful tool in certain cases. Now you can see 4-nitrochlorobenzene or 4-chloronitrobenzene, which minus attack on the carbon additions occurs slow, and then eliminations of chlorine and hydrogens, which is the first. So additions first and then eliminations, and again OH minus trap these hydrogens and forming these products. So this carbanion is mesenchymal intermediates. This carbanion is mesenchymal intermediates. So actually this carbanion is formed when attacked with the hydroxide ion. Now friends, nucleophilic aromatic substitution reaction is superficially similar to the SN1 and SN2 nucleophilic substitutions. Aryl halides are inert to both SN1 and SN2 conditions. Mechanism must be different. You can see chlorobenzene. If it is removed, then positive charge will create sp2 orbitals, which is unstable cations. Now in the another case, if nucleophile attack on chlorine, then backside displacement is sterically blocked, therefore no SN2 reactions. So mechanism SN aromatic mechanism addition eliminations, SN1 mechanism Benzyne mechanism elimination additions, and SRN1 mechanism. So SNAR aromatic mechanism, first addition and elimination. Nucleophilic aromatic substitutions of the type just shown below is an addition elimination mechanism. You can see electron withdrawing groups ortho and para stabilizes the intermediates. So ortho, there is a chlorine attack and then OH minus on there, then resonance stabilize, and then you can see the ortho nitrophenols, and then para you can see first additions and then eliminations, and meta you can see. So intermediate mesenchymal complex is stabilized by electron withdrawal. This is stabilized by electron withdrawal in it. Halide ion is lost to give aromatic ring. Now the rate determining intermediate is cyclohexadienyl anion and is stabilized by electron withdrawing substituents, especially in position ortho in para to living groups. Attack of the strong nucleophile on halogens substituted aromatic carbon forming and anionic intermediates, and loss of living group, the halide ions, restores the aromaticity. The addition step is the rate determining step, loss of aromaticity. Now friends, nucleophilic substitutions and therefore reaction rate is facilitated by the presence of strong electron withdrawing groups, for example NO2, ortho and para to the site of substitution, which stabilize the cyclohexadienyl anion through the resonance. You can see here OH minus attack on chlorine carbon, and then they create a lot of resonating structure. So this is the reason of stability. So if you have aryl halides reactivity like fluorine greater than chlorine greater than bromine greater than I, means iodine. Now friend, benzyne in mechanism. Benzyne mechanism. So this type of mechanism occurs on aryl halide that have no activated groups. Stronger bases are required. The incoming group doesn't always take the positions vacated by the living groups. So you can see NH2 group is taking these hydrogens, and then you can see the formation of benzyne. So this is actually first eliminations and then additions, and then addition of NH2 and forming an ellipse. Now friends, aryl halide undergoes substitutions when treated with very strong base. Now reduce chemistry. New substituents becomes attached to either the carbon that bore the living group or the carbon adjacent to it. NaNH2 ammonia minus 33 degrees Celsius. It gives at 2 positions and 3 positions. Now new substitution becomes attached to either the carbon that bore the living groups or the carbon adjacent to it. For bromotoluene, so NaNH2 ammonia minus 33 degrees Celsius, it gives these two products. So regiochemistry minus 33 degrees Celsius, it gives three products, ortho, meta and para. Same result using carbon 14 label. You can see 52% these products and 48% another products. So my compound formed in this step is called benzyne. You can see the formation of benzyne and addition of NH2. Angle strain is relieved. Angle strain is relieved. The 2sp hybridized ring carbon in benzyne become sp2 hybridized in the resulting anion. You can see here how NH2 minus again taking these protons and forming anion. Now other routes to benzyne is like that. You can see the formation of benzyne and the formations of products. Trapping of intermediates. Benzyne intermediates have been trapped through the use of Diels-Alder reactions. One convenient method for generating benzyne is the diazotization of ethanoic acid, followed by elimination of CO2 and N2. So ethanoic acid diazotizations forming benzyne trapped in C2, and benzyne react with furan forming Diels-Alder products. SR-N1 mechanism. You can see the iodine, you can see the formations of radical here and attachment of NH2, and again the position change of iodine and forming NH2. So to explain this, it has been proposed beside the benzyne mechanism, the free radicals mechanism is also operating here. So ARX minus radicals, AR radicals X minus, AR radicals nucleophile, AR nucleophiles radical anion, radical anion react to RX, give RNU plus RX radical anion. So Rx nucleophile give R nucleophile Rx minus. This is called as SR-N1 mechanism. SR-N1 mechanism. And electron donor is required to initiate the reaction. What is the evidence? Addition of potassium metal completely suppresses the sign substitution. Now friends, our target, bone-richer rearrangement. Bone-richer rearrangement. Aromatic nitro compounds on treatment with cyanide ion. The nitro group is displaced with the carboxyl groups with syn substitutions. Always ortho to the displaced groups, never meta or para. You can see the products. What is the mechanisms? You can see the mechanisms. These NO2 groups. Now nucleophile attack. There is a formations of these two products. Then many steps. You will see the formations of the products. Now friends, SMILE rearrangements. Intramolecular nucleophilic aromatic substitution of type SMILE rearrangement is like that. Here W, X and Y, there is a functional groups, where X is the arene compounds can be sulfone, sulfide and either or any substituents capable of dislodging from the arenes carrying a negative charge. The terminal functional groups in the chain and Y is able to act as the strong nucleophile for instance an alcohol, amine or thiol. Now friends, Sommeler Hauser rearrangements. Benzylic quaternary ammonium salt when treated with alkali metals amide undergo rearrangement give benzylic tertiary amides. Now friend, Chichibabin reaction. The reactions of pyridine with sodium amide to give 2-aminopyridine. This is the mechanisms. So friends, hope this video will be helpful to you. If you like this video, then share it in your friend circle and subscribe my channels. This is my request to you. So thanks for watching friends.